You might have heard of a term called antimatter. Just observing the name would tell you that it is the opposite of matter, but what is it truly? To put it simply, it's composed of antiparticles that have the same mass as their counterparts but have opposite electric charge and other quantum properties. As you know, matter is made up of atoms, which in turn are made up of protons, neutrons, and electrons. Antimatter is also made up of these particles, but with a twist: every particle in antimatter has an opposite charge. For example, the antiparticle of an electron is a positron, which has a positive charge instead of a negative charge. You might be wondering whether antimatter is real or not, and the simple answer is, yes, it is real and can be created in several ways. One way is through the decay of certain radioactive materials, such as potassium-40. Another way is through the collision of high-energy particles, such as those produced in particle accelerators. Several experiments at CERN create antihydrogen, the antimatter twin of the element hydrogen. The most complex antimatter element produced to date is antihelium, the counterpart to helium. There are also naturally produced antiparticles made sporadically throughout the universe. But when matter and antimatter meet, they annihilate each other and produce energy, meaning that in a matter-dominated cosmos such as ours, antimatter doesn't stick around very long. After the Big Bang, the universe started as energy and then produced particles of matter and antimatter as it expanded and cooled. Matter and antimatter have been found to behave identically, and if they were created in equal amounts, they should have annihilated each other, leaving nothing behind. So why did matter come to dominate over antimatter? According to a theory, the universe may have created more matter than antimatter in the beginning, allowing for the formation of stars, galaxies, and everything on Earth. The difference between matter and antimatter would have been extremely small, with less than 1 in 1 billion ordinary particles surviving to create the matter around us today. The neutrino, a subatomic particle that barely interacts with other matter, could be the solution to the mystery of the universe's matter-antimatter imbalance if it is found to be its own antiparticle. According to this theory, a small portion of neutrinos might have transformed from antimatter to matter in the beginning, causing a slight imbalance in matter. Scientists have conducted experiments to verify this theory but have yet to obtain conclusive results. Because putting matter and antimatter together produces energy, engineers have speculated that antimatter-powered spacecraft might be an efficient way to explore the universe. NASA has studied the possibility of using antimatter-driven vehicles to fly to Mars, but the idea has some downsides. For one, it's really expensive. The cost of producing 10 milligrams of positrons, which are required for a human Mars mission, is roughly $250 million using presently developing technology. So this concludes my discussion of antimatter. I hope you found it informative and thought-provoking. Please like and comment your thoughts and do subscribe to my channel. Thank you for watching.